Let's practice finding left-hand Riemann sums. So the directions here say to calculate the left Riemann sum for 400, and n rectangles for f of x equals 5 minus 1/2 x squared on the interval from 0 to 2. So here I've printed the formula for the left Riemann sum. So area equals the sum of f of a plus k minus 1 delta x. So that expression gives the height of the kth rectangle, so the height of each rectangle, and then all of that times delta x, and that gives the width of each rectangle. Right, so we're summing up the area of each rectangle, and this gives us a generic formula for how to do that. Now over to the side here I have this is a really rough sketch, right? I just drew this really fast, but a sketch of these rectangles. And you can see that this is going to be actually an overestimate for the area under the curve. Okay, so let's start calculating these values. So we want to start by calculating or approximating the area for 4 rectangles. So here I have the function and the interval, and we're going to use this formula for left Riemann sum. So we want to start by just finding the different pieces that are important to our formula. So since we're doing in 4 rectangles, we know that n equals 4. And if I look up at my formula, I've got this a, right? Little a is part of my formula. That represents the left-hand endpoint of the interval, right? So 0 to 2, 0 is a and 2 is b. So a is 2, or sorry, a is 0. And then I also need delta x, right? So up here in my formula, k is just the index of the summation. It's a variable I'm summing over. But delta x, I need an expression for that. So delta x in general is b minus a over n, which in this case would be 2 minus 0, 2 over 4. So 1/2. Okay, so once I have that information, I can go ahead and plug in to my area formula. So I have the sum from k equals 1 to n, which is 4, f of a, which is 0, plus k minus 1 times delta x, which is 1/2, and all that's times delta x again, which is 1/2. Okay, so this 1/2 here, I can pull out front. That's a constant multiple. So 1/2 times the sum. F of 0, the 0 goes away, so I have f of k minus 1 over 2. Okay, so what do I do next? Well, this notation, f of k minus 1 over 2, that's telling me take k minus 1 over 2 and plug it into f. Okay, so that's what I'm going to do next. Okay, so if I take that entire expression and plug it in for x in my function, I get 5 minus 1/2 times k minus 1 over 2 quantity squared. Okay, and I want to keep simplifying this because eventually I hope to use my summation formulas. So 5 minus 1/2 times, okay, so this is going to give me k minus 1 squared over 2 squared, which is 4. Okay, so 1/2, k equals 1 to 4. So I could write this as 5 minus 1/8. I'd like to multiply this out. So k minus 1 quantity squared, you have to FOIL that. Okay, so that's k minus 1 times k minus 1. So it's going to give me k squared minus 2k plus 1. Okay, always remember to FOIL those. And then if I distribute my 1/8, 5 minus 1/8 k squared plus, be careful with your signs, plus 1/4 k minus 1/8. And maybe one more step here before we start using our summation formulas. I've got 5 minus 1/8. So that's 40/8 minus 1/8. So that's 39/8 minus 1/8 k squared plus 1/4 k. Okay, now I'm trying to get a numeric value, right? I mean, I've got 4 rectangles and they each have an area, so there's some numeric value to all this. So how do I get that? Well, what I'm going to do is is use my summation formulas. So remember, we have nice formulas for like the sum of k squared, the sum of k, or the sum of a constant for some value of n. Those are what I'm going to use next. So to make it a little easier to see how to use those, let's actually split up this summation. So I have this 1/2 out front, and that's going to stay out in front of everything. But I have 3 terms in my sum, so I can split this up like this. 39 over 8 minus 1/8 times the sum of k squared plus 1/4 times the sum of k. Like that. Okay. Now, I want to use my summation formulas. Okay, so let's apply them. So we still have this 1/2 out front. But now I have the sum of a constant. Okay, so if I look at this formula here, that should be that constant times n, and n here is 4. So 39 over 8 times 4 minus 1/8 times the sum of k squared for n equals 4. So here's that one, and I plug in n equals 4. Gives me 4 times 4 plus 1, which is 5, times 2 times 4 plus 1, which is 9 over 6, plus 1/4 times the sum of k. Okay, so here's my k formula. It's n times n plus 1, so that's 4 times 5 over 2. Okay, so now we have this big, nasty expression, but all you're going to do is plug and chug into your calculator, and if you're careful, you should get 9.125 for your final answer there. Okay, so we just approximated the area with 4 rectangles, and that should be an overestimate, remember. Okay, so next we're going to do 400 rectangles, and we're just going to do the same thing again, but our values are going to be different. So once again, our sum for a left-hand Riemann sum looks like this: f of a plus k minus 1 delta x, that's the height of each rectangle, times delta x, the width of each rectangle. F of x was 5 minus 1/2 x squared, and our interval was from 0 to 2. Okay, so what are the values we're going to be using in our formula? Well, here n equals 400. Little a still equals 2. That's just my left-hand endpoint of the interval. So, sorry, I think I said 2, but a equals 0, right, the left-hand endpoint. Once again, k is just the index of summation. Delta x is b minus a over n, so that's 2 minus 0 over 400, which is 2 over 400, which is 1 over 200. Okay, so let's take all of that and plug it in and calculate the area. So I'm summing from k equals 1 to 400, right, because I have 400 rectangles. And then I have f of 0 plus k minus 1 times delta x, which is 1 over 200. And that's all times 1 over 200. Now once again, this 1 over 200 is a constant multiple, so I'm going to pull that out front. Okay, so I end up with f of k minus 1 over 200 inside the summation. Now once again, what this notation means is to take this k minus 1 over 200 and plug it into my function. So if I do that, and I still have my constant out front and I still have my summation, but I'm plugging in k minus 1 over 200 for x. So I have 5 minus 1/2 times k minus 1 over 200 quantity squared. All right, now comes the kind of nasty algebra. Okay, so 5 minus 1/2, this is going to be k minus 1 quantity squared over 200 squared, which is 40,000. All right, so then that is, so I can write this as 5 minus 1 over 80,000 times, so this is k minus 1 quantity squared. We just did that above, right? That was k squared minus 2k plus 1 if you FOIL it out. So then, if I go ahead and distribute that 1 over 80,000, I have 1 over 80,000 k squared, 2 over 80,000, which is 1 over 40,000, and this should be plus because it's minus a negative. Okay, minus 1 over 80,000. Okay, so that's a little bit messy, right? So once again, we've got two constants. We've got 5 minus 1 over 80,000. If you combine those, what you get is this nasty number, 3 with 5 nines, over 80,000. Okay, then I've got minus 1 over 80,000 k squared plus 1 over 40,000 k. Okay, now, oops, that k should not be in the denominator. So now I'm in a similar situation to what I was before, right? I've kind of simplified this as much as I can, so I have either constants or constant multiples of k and k squared, and all those things are things I know how to use my sum formulas on. So that's what I'm going to do next. Although first, it might be nice just to split this up. Okay, so I have this guy, this constant, minus, I can pull out the 1 over 80,000 times the sum of k squared plus 1 over 40,000 times the sum of k. And now I can apply my formulas. Okay, so if I do that, I have this constant. Remember we said that if you're summing a constant, it ends up equaling that constant times n. So here, n is 400. Okay, so it's going to be this times 400 minus 1 over 80,000. And I didn't recopy the formulas here, but remember k squared was n plus 1, 2n plus 1 over 6. Okay, so here I've got 400, so n is 400, n plus 1 is 401, 2n plus 1 is 801, and that's all over 6, plus 1 over 40,000, and the formula for k was n times n plus 1 over 2. So that's 400 times 401 over 2. Okay, and once again, this is nasty, but if you carefully put it into your calculator, maybe piece by piece, you should get approximately, right, I rounded this, approximately 8.67. Okay, now does that make sense? Remember, this should be a better estimate because we used more rectangles. And remember we said that this was an overestimate, so a better estimate then should be less, right? And it is. I went from 9.125 to 8.67. And if you watch the video on the right Riemann sum, we actually got something quite similar to this. I believe we got, let's see, 8.66. Okay, so really close, and that makes sense because we have a lot of rectangles, so the left and right are pretty close. All right, but the last thing we want to do is we want to find a general formula just for any number of rectangles. So I want to do the same process for n rectangles. Okay, so let me write down the formula just one more time for us here. It looks like this. And f of x, 5 minus 1/2 x squared from 0 to 2. Okay, so here n is just n. We're not using a specific numeric value. A is still 0. Delta x is b minus a over n, okay, which is 2 over n in our case. And once again, we're just leaving it in terms of n. Okay, so what's it look like if we plug this in? Well, n just stays n, right? So from k equals 1 to n, f of 0 plus k minus 1 delta x, and delta x is 2 over n, times 2 over n. Now notice that I'm summing over k, right? K is my index of summation. So 2 over n is actually a constant because it doesn't contain a k. So I can pull it out front of the sum. And I have f of 2 times k minus 1 over n. All right. So once again, we're taking this 2 times k minus 1 over n, and we're plugging it in for x in our function. So what does that look like? 5 minus 1/2 times this whole expression, 2k minus 1 over n, quantity squared. So if we actually square that, 5 minus 1/2 times, square everything, so 4k minus 1 squared over n squared. Okay, so then we're going to keep working here. Remember, we want to get this down to those basic parts that we can use our summation formulas on. So 5 minus 1, okay, so I've got a 4 over a 2, right? So that's going to simplify to a 2 in the numerator. N squared, and then k minus 1 squared again, so we foiled that before. It's k squared minus 2k plus 1. Okay. And I'm going to follow a similar pattern to what I've done for the other ones. I'm going to multiply this out. So 5 minus 2k squared over n squared minus, or sorry, plus, it's minus a negative, 4k over n squared minus 2 over n squared. Okay, now I've got this down to its little pieces. I've got a constant 5, I've got something times k squared, I've got something times k, and then I have this other constant 2 over n squared. So once again, I can split this up. Okay, so the 2 over n is going to be in front of everything, and then I'm going to have the sum of 5 minus, okay, remember that n is a constant because I'm summing over k, so this is 2 over n squared times the sum of k squared plus 4 over n squared times the sum of k minus the sum of 2 over n squared, that's a constant. Okay, and then we apply our formulas. So the sum of a constant is that constant times n, so this is going to be 5n, minus 2 over n squared times the sum of k squared, okay, which was n plus 1, 2n plus 1 over 6, plus 4 over n squared times the sum for k, which is n plus 1 over 2, minus, okay, this is the sum of a constant, so it should be 2 over n squared times n. All right, so let's do a little cleanup. So in this second term in the brackets here, I've got an n on top, n squared on bottom, 2 on top, and a 6 on the bottom. So if I reduce that, that's n plus 1, 2n plus 1 over 3n. Here I've got 2 on top, 2 on bottom, 4 on top, And I have n's that can cancel as well. So I end up with 2 times n plus 1 over n minus 2 over n, if I simplify that. And let me just distribute this 2 over n. So that's going to give me 10n minus 2n plus 1, 2n plus 1 over 3n. Plus, it should be a plus 4n plus 1 over n squared minus, sorry, I keep seeing little mistakes here. There's so many terms, right? This should not be a 10n. It should just be a 10. Okay, so just 10 because the n's cancel. Okay, and then my last term, 4 over n squared. Okay, so that's a big old mess, but that's our answer. Okay, so kind of like I was doing, just sort of check yourself as you go along and look back and make sure that you caught all the pieces. But this is the area for any value of n. So if you take this and you plug in 4, you should, if we did it right, you should get what we got for 4 rectangles before. And if you plug in 400, same thing, you should get what we got for 400 before. So this is how you use the left-hand Riemann sum formula.